Alright, hello, welcome back. So in this video I'm going to talk about how to use Excel to find the price of a bond. And there's actually two functions we can use. We can use the PV function, which we've already covered, or we could use something called the price function, which is a bond-specific function. And I'm going to go over both, and I'm going to go I'm going to use this example. And so in this example, we have a 25-year bond, okay, 25-year bond as matures in 25 years, has a coupon rate of 4.7%, right, and a par value of 1,000. And at first, I'm going to assume annual payments, right? Um, but later on, we'll also show how, and it's not that big of a change, but we'll also show how to do it in the case of semi-annual payments, okay? All right. And so basically, if payments are made annually, the coupon's going to be, well, 4.7% of 1,000. That means $47 paid each year for 25 years. And in that 25th year, when it matures, you also get that 1,000, making that last payment 1,047. Okay, so let's first calculate it, and I have three different yield to maturities here we could use. We're going to use this one highlighted in yellow, right? 2.1%, right? And you should know from the previous video that because the yield to maturity is less than the coupon rate, the bond price that we're going to get should be higher than 1,000. Okay, so I'll just click here, and we'll calculate the bond payment for annual payments, right? So I'll be equal sign. Right, we'll start with the PV function. So the rate in this case is the yield to maturity, so that's 2.1% or 0.021, comma, number of periods, so it's annual payment, so it's a number of periods should be 25. Payment, as we see on the timeline, it's 47, comma. Also, don't put the dollar signs in there. I don't know if you probably figured that out already, but okay, so that's the payment. Now, here's the tricky thing. This isn't quite an annuity. A bond is not quite, it has an annuity component, but it also has a lump sum component, right? So we have a payment of $47 each year, right? That's why I showed. But because we also have this $1,000 lump sum, we actually also have a future value in this case. And in this case, the future value is just the par, so it's 1,000. Okay, so a bond function, finding a bond price is kind of like, using both annuity and lump sum formulas, and that's why we're using both the PMT. We're putting an input both in for PMT and in FV, and then the type. It's just, well, type's always going to be 0 for bonds because bonds, it's their first payment comes a year from today. Okay, so put 0. And we can see, yeah, the price of this bond is going to be $1,501.70. Okay. Now, that's if payments are made annually. Now, if payments are made semi-annually, then things are going to be slightly different. So I'm going to I'm going to put things in here. I'm going to use these little spaces here to actually kind of do the semi-annual calculation. But if it's semi-annual, then we have two semi-annual periods per year, and so for 25 years, that's 2 times 25, which should mean there's 50 periods we're looking at. The coupon payment, we already know it's 4.7% of 1,000, or $47 per year. So if payments are made semi-annually, that's going to be 47 divided by 2, the $23.50 per half period, per 6 months. The yield to maturity in this case, we actually have to also change this. This has to be changed to 2.1%, or 2.1% divided by 2. So we got to do equal sign 0.021 divided by 2. And then for the face value, that's still 1,000. Okay. And so what I'll do in this case, I'll just do, again, the PV function, equal sign PV, open parentheses. The rate, I'll just put yield to maturity, comma, number of periods, the maturity here, payment, coupon payment there, $23.5 per every 6 months. Future value is 1,000, comma, and then of course 0 for type, and we get a slightly higher bond price, but by and large it's the same, right? So it increases the price a little bit, and that's only because the first payment comes sooner. with the semi-annual than it does with an annual. Okay, so that's how to find the price of the bond with the PV function. Now let's use the price function. Okay, so you're probably familiar with the inputs on the PV function by now, so I'm just going to type in the price function at first just to show you what the inputs are. We have a settlement, maturity, rate, yield, redemption, frequency, and basis. Okay, so settlement is basically settlement meaning the date we buy the bond, right? This has to go in as a date, right? So this is basically our start date. Maturity in this case is the end date, the date at which the bond matures. So unlike in the PV function, we actually have to put two dates into this function, right? And it's going to go ahead and figure out how long is left, okay? Rate in this case is not the yield to maturity. Notice we have another input for yield to maturity. Rate is the coupon rate. Yield to maturity, as I've already said, is yield to maturity. Redemption, that is what percent of par, right? Now, in most bonds, 100% of par gets redeemed once the bond matures. There are some cases where bonds, if maybe they're in bankruptcy or something, they might default on part or all of the par. And in that case, you would put less than 100, but as long as they're getting 100% of par back at maturity, you just put 100 for redemption. Frequency, that's whether or not it's paid. The coupon payment is made annually, semi-annually, or quarterly. And then basis is it's usually not a big deal. Usually we'll just go ahead and put 0 for it, but it just has to do with how we determine a year, right? Depending on which exchange you're doing it, they're gonna either assume there's 360 days in a year, or sometimes they might assume it's 365, or sometimes if it's a leap year, it'll be 365.25, or sometimes they'll actually use the given date. And so, but usually we're going to use the U.S. NASDAQ basis, which is 0. It's standard, so we probably won't even have to put it, but you can just put 0. All right, so when we put these dates in, we have to use the date function. So that's why I'm going to go ahead and do it using these input cells down here. So settlement date. Now, as long as the difference between the settlement date and the maturity date is 25 years, it doesn't matter what date we choose as a settlement date. Right? So you could choose today, you could choose Christmas, you could choose your birthday, anyone. So I'm going to choose today, right? So I'll do date =, date, open parentheses, the year, it's 2023, comma, the month, well, it's June, which is the 6th month, so 6th day is the 12th, and I'll close parentheses, and of course that'll give me that. Then =, then maturity date, that'll be due date, open parentheses, and this date is basically today, but in 25 years, so it's going to be 2023 plus 25, comma, the month, again, is 6, and then the day, of course, is 12. And then again, that's just going to be, June 12th, but in 2048. The rate is our coupon rate, so that in this case, that's 0.047. Yield to maturity is 2.1% or 0.021. Redemption, as I said, if there's no default on any of the par, you just always put 100. So we'll put 100, and then the frequency, we'll start off with annual frequency, and then we'll change it to, semi-annual. So we'll put 1, and basis we'll put 0. All right, so let's go in there now. Let's use =, price. We'll do the settlement date. Click this for the settlement, comma. Click maturity, comma. The rate, comma, yield to maturity, comma, redemption, comma, frequency, comma, and then 0. Well, I'll just click that. Yeah. Okay. Now, before I click enter, you're going to notice something slightly different about this price, and that's because the price, using the price function, always gives you a price that's a percentage of par. Okay. As opposed to the PV function, it's not, it's going to be based on, the price is just going to be in dollars. But in this case, it's going to be as a percentage of par. And basically, you don't, it always calculates everything as a percentage of par. Um, so in this case, we're going to get 150, right? 0.17008. So the price is basically 150%, 150.17% of the par, right? So if we wanted to turn this into an actual price, right, we'd have to take, right, we'd have to turn this into, we have to convert this into decimals. So basically we have to convert this into decimals. So we divide it by 100, but then, we put it all in terms of, well, the par value, which is 1,000. So multiply this by 1,000. All right, but this is basically the same thing as multiplying this by, that's basically the same thing as multiplying this by 10, okay? So with a price function, you're always going to need to just go ahead and multiply it by 10, okay? All right, so we get the same thing. Notice we get the same thing for annual payment, right? $1,501.70, right? Either way. Now, if we wanted to change it to semi-annual payments, all we have to do is press 2, okay? And again, we get the semi-annual. If we want to do quarterly, we get a slightly even higher, but right? All right, now one final note. Again, redemption is always 100. Don't ever put anything else. And then settlement, you always have to put these in as dates. So, I would, if you're going to use a price function, it's probably best to go ahead and write out the usual inputs and do it like this, as opposed to doing what we've done with some of the PV functions, right? But you can do it. Just note that for these settlements, for the settlement date and the maturity date, those have to be inputted using the date function. It has to use this serial number that Microsoft Excel has input. All right, so that'll do it for this one. You'll hear from me again. All right.